Okay, continuing on some of the chapter 6 quiz problems. So find the area of the shaded region. The graph to the right depicts IQ scores for adults, and those scores are normally distributed with a mean of 100 and standard deviation of 15. What we're going to notice here is it's between two different numbers. So what we're actually going to have to do is we're going to have to calculate the z-score for both of them. And what we're going to do is we are going to take the larger amount and then subtract away the smaller amount. Because if we want everything just between the shaded region, once we find to the left of 130, we're going to have the excess of less than 104. So let's jump into Excel and write some numbers down. So the first one is we have 130. The mean is 100 and a standard deviation of 15. We also have a second set where we are going to have to find to the left of 104. So again, my z-score, my numerator is equal to my data minus my mean. So 130 minus 100 is 30. And that standard deviation is 15. So we need to do 30 divided by 15, which is going to equal 2.00. We're going to do the same calculation here. 104 minus 100, which is 4. Standard deviation is 15. Remember, there's no sample size, so we're not dividing by anything. We're just using the standard deviation. 4 divided by 15, 0.2667. So this is going to be another one that this number might have a couple different options. The reason for that is because we rounded this guy. So we want to go into the positive table. Again, this is another one. Let's go back to question 2 just to get the table that we need. So what you would have to do is you'd have to print out these z-scores before the quiz actually began. So let's look for 2.00. 2.00 is going to be 0.9772. So that means the area to the left of 130 is 97.72%. Now let's look for the 0.27. 0.2 across the top, 0.02 on the left, 0.07 on the top, 0.6064. So 0.6064 is that area to the left of the 104. So that means the area between all the way to the left of 130 is going to be 0.9772, and all the way to the left of the 104 is 0.6064. So to find the number that we want, we need to take 0.9772 and subtract away 0.6064, and that's my 0.3708. And notice that's that second answer there. 3721 would have been if we did that rounding and that exact interpolation, but you don't need to. So in order to do between, you have to calculate two separate z-scores, look them both up in the table, and then do the subtraction. So for this question, find the indicated z-score. Graph depicts a standard normal distribution with a mean of 0 and a standard deviation of 1. That means we don't need to do any adjustments with our z because our z is our value. So this is showing me that 0.9162 falls to the left of that z value. One thing to know is that anything to the left of 0.5 for a percentage is going to be a negative z value, and anything greater is going to be a positive z value. So we automatically know we have to go to the second table. We're looking for 0.9162 inside of the table and then working backwards. 9162 is actually right here. So if I go to the left, that's going to be a 1.3, and I come up 8. So 1.38 is going to be the area to the left. So 1.38. And so you answer the negative. For it to be negative, that would have actually been on this table right here. And a negative 1.38 would have had 0.0838 to the left of it. So you have to be really careful with that positive and that negative piece of it. So a negative z value is going to be percentages between 0 and 50% because that's below the mean. And anything 50% or higher is going to have a positive z-value because that's above the mean. So assume the adults have IQ scores that normally distribute with a mean of 100 and standard deviation of 20. Find P sub 10, which is the IQ score separating the bottom 10% from the top 90%. So in order to do this problem, we have to do what we had just done in that last problem. So what we're actually going to find is 10% inside of the table. So that means it's going to be the negative table. So I want to find inside of my table the closest value to 0.1000. So if I come on down and I look, the closest is going to be 0.1003 because that's going to be 0.0003 away, whereas this guy right here is 0.0015 away. So if I come to the left, this is a negative 1.2, and if I come to the top, it's 8. So the z-score associated closest with 10% is negative 1.28. And so now what we have to do is we know that our mean is 100. And we know that our standard deviation is 20. Our formula here is my z is equal to what? My data minus my mean divided by the standard deviation. So if I multiplied both sides by my standard deviation, I would have z times that standard deviation. And that's going to equal what? That's going to equal my data minus my mean. But I'm looking for that data value. So we're going to add my mean to both sides. So now if I have z times my standard deviation plus that mean, I now have a formula for what? For what that data value is going to equal. So now this is going to be my z-score of negative 1.28 because I want less than 0.10, 10%, and that's the z that goes along with it. My mean is 100 and my standard deviation is 20. So if I do that z-score of negative 1.28 times that standard deviation, I then need to add to that my mean of 100. So 100 plus negative 1.28 times 20 gets me 74.4. And so the IQ score is going to be that 74.4. Again, remember, everything comes down to that little bit of rounding. We used 1.1003 as opposed to exactly 0.1000. So if we had made that slight adjustment, it would have actually been 74.37, but as all intents and purposes for this class, 74.4 is exactly precise. So that's where that guy comes from. I hope this helps. If you have any other questions, please reach out and let me know.